everybody. So this problem on the homework where you were supposed to classify the symmetries of a diagram, I assigned it. I thought I knew the answer, and then you all gave such convincing but completely different explanations for what it was that I got hopelessly confused, and my grading was all over the place. So in the end, I went back and gave everybody full credit, and let me see if I can explain what I believe to be the correct answer to the classification of this problem. So here's the relevant picture, which was taken from the text, and it's up here. And we want to try to figure out what the symmetry is here. And the first step is to find a good fundamental cell for the lattice. And there's actually several possibilities for this, but the points that leap out to me are the points like this, which have 6 diamonds meeting at them. And so let's draw a cell of the lattice by connecting points which are closest to each other and which have 6 diamonds meeting. And that gives us a fundamental cell, which is, I guess, what you would call a rhombus, which looks like that. Okay? And so now, when we're setting out to classify what type of diagram we have here, we want to look, first of all, for the types of rotational symmetry which the picture has. And this is one of the things which confused me, because several of you pointed out that it was a P6 symmetry of some kind, and I said in the solutions, oh, there's no 6-fold rotational symmetry. But of course, I was being stupid. There is a 6-fold rotational symmetry about this point, where these 6 diamonds rotate around each other. And then, for instance, this diamond goes here, this diamond goes here, this diamond, you can't see what I'm doing. This diamond here would go here, and then to here, and then to here, and then to here, and then to here, and then around, and so forth. And so there is a 6-fold rotational symmetry at this point. Now, what other types of symmetries are there? Well, there's the other thing that people noticed is that there are reflections. So let me draw in some axes of reflection. So first of all, there's an axis of reflection that runs this way through the cell. Because if you reflect vertically, like this, the diagram is preserved. And there's also an axis of reflection which goes this way. Because if you reflect around that angle, this diamond here goes to this diamond here. This diamond reflects around itself. And similarly, I guess, you have an axis of reflection which goes this way. And I believe you also then have, there's even more, but for instance, there's a vertical, you can reflect through this axis. But let's focus for the moment just on the 2 that I drew at the beginning. So the one which goes at this angle, and the one which goes at this angle. And now let's take a look at the classifying diagrams and see if we can figure out what's going on. So in the classifying diagrams, we've first of all decided that we have a 6-fold rotational symmetry. And that boils down our choices to one of these 2. So I'm going to copy them up here so we can look at them more closely. So one of them, the one on the top, has a 6-fold rotational symmetry based at the origin, but it has no reflection symmetries. And if you can read either diagram. This one, if you read this diagram, what it's telling you is that there's you can make this picture by drawing this triangle, which I think is a isosceles triangle where you have 30-degree angles at the base here, and then a 120-degree angle at the top. And you can rotate it around 180 degrees to here. And you can also rotate it 120 degrees like that and fill up the basic cell with triangles in this way. Now, an interesting fact about this is that if you go back to our picture, it's true that there's what looks like a reflection symmetry across this vertical line, but you could also view that as a 180 degree rotation around this midpoint. But now let's look at, but as we said, our picture has these other reflections in it. It has this reflection, if here's the basic cell, it has a diagonal reflection, and it also has this reflection at an angle. And that means we must be in this case here, because this is the case that had this line here means that there's a reflection around the diagonal of the basic cell, which is based at the place where you have a six-fold rotation. And that's what we have. We have this diagonal reflection based at the point where we have a six-fold rotation. And the meaning of this diagram is that if we wanted to eliminate the translations and only use reflections, that if we took this little triangle in here, and I will color it with some other color maybe so we can see it more clearly, this little triangle right here, and reflected it around, it would give us the total picture. And the thing that's important about this triangle, let me look at another example of it. It's if I was to go over to here and take this edge and then go down like this to here, I guess, bisecting this line, this little triangle here. I think that's the right triangle. No, that's the wrong triangle. I can put in this, put in this here, and this here, and take this little triangle here. You notice that it only has a filled in edge on one side, and the other sides are open, and that's okay, because that's why when you reflect it around, it's going to give us the correct picture, because it's going to leave these diamonds open. And when we reflect over here, and so on. So you could view this whole picture as being made by taking this little 30, 60, 90 triangle where I guess only one of the sides actually has a line and the other two sides are open, and reflecting that around. Namely and you have three axes to reflect it by. You can reflect it if I draw the triangle like this. So it only has the, let's try see if I can draw this. It looks like this. There's a reflection around the base of this side, all three sides of the triangle. So it goes like this, and also like that, I guess. And then you would keep reflecting, but you only have one piece of two of the lines are missing that make up the triangle. So I think that's right. I think it's P6M symmetry. But if somebody has wants to make an argument with me that I have screwed something up, I'm certainly open to hearing opposing points of view. But I think I'll stop talking there.